Bueno, buenas noches a todos y muchas gracias por venir a esta cuarta edición de Kaggle Days Meetup. En primer lugar, agradeceros a vosotros venir y a nuestros sponsors Platinum, Banco Santander, y a nuestros sponsors Gold, Ayesa y Terminus 7, por hacer este evento posible. Muchas gracias a Google Campus por cedernos este espacio, sin él tampoco sería esto posible. Hoy queremos compartir con vosotros que hemos comenzado este mismo Meetup en Sevilla este sábado. Ha sido un éxito muy grande por las críticas que hemos ido recibiendo y estamos muy contentos. Luego hablaremos un poquito más sobre eso. Hoy tenemos a Gilberto Titericz. Gilberto es ingeniero electrónico, tiene máster en telemática, ha trabajado como ingeniero para Nokia, Siemens y Petrobras. También ha trabajado como científico de datos para Airbnb y actualmente él es Lead Data Scientist en Ople. Gilberto tiene 47 medallas de oro en Kaggle. Estamos acostumbrados a tenerle desde años como número 1 y para que os hagáis una idea, os voy a dar un dato. Este hombre tiene más medallas de oro que medallas de plata o que medallas de bronce. Y os voy a contar una anécdota. Kaggle cambió la fórmula por la que hace el ranking y tuvo que meter un factor decay. De esta forma nos ha ayudado a los mortales a poder entrar en ese top. Porque ¿cómo compites con 47 medallas de oro, sabes? Sería imposible. Y entonces, dicho todo esto, os quiero comentar que ha viajado más de 24 horas desde Brasil y otras tantas de vuelta solo para estar hoy con vosotros y hace 2 días con el público de Sevilla. Entonces, quiero pedir para él un cálido aplauso, por favor.
Hola. Okay, better. Okay. First of all, I'd like to thank the organizers and the sponsor to invite me to be here tonight. I have 2 talks tonight. I hope it's not so exhausting to everyone. They are long talks, around 50 slides each one, but both talks are very interesting topics to me. I will start with challenges in automated machine learning. It's related with my current job, and it's a topic that I love it. Okay, first of all, what is auto machine learning or AutoML, right? There are many definitions. I like both the weak definition and the second one. So it's the process of automating end-to-end the process of applying machine learning to real-world problems, right? Or it's an intuitive tool that enables anyone to do machine learning and a productive tool for data scientists. The second one definition is pretty interesting because it says everyone can use AutoML. And the last one, AutoML is a form of AI that can build AIs. So in definition, it's pretty simple. The idea is to have not a black box, but a system, a tool, a pipeline that you can input data, and the output is going to be a model that understands your data in all possible ways. And so in the future, you can just add new data to that model and have the predictions on the output, right? So it's pretty simple. This is a macro vision of how it works. But why AutoML? There are many reasons. One is the amount of data the world generates today, right? Every day, we estimate to generate 2.5 zettabytes of data, right? Imagine data scientists processing this amount of data manually or doing exploration of the data or some manual tool to process all this data, right? So AutoML is something that can be used to make this job done in a reasonable amount of time. Also, demand for data scientists, right? Everyone knows there's a big growth in the demand for data scientists on the last years. This is a survey from LinkedIn. They estimated 12 times growth on the last years. Also, there's some numbers in different cities of the US. For some cities, the growth is much bigger than other cities, but everyone knows there's a growth. I can see that growth in Brazil right now. And I see this big demand in the US when I was been working there. Okay, so another why. Why use AutoML? This is an experiment I made, trying to understand how hyperparameter tuning can help with the accuracy or performance of the models. So this is a pretty simple experiment. I run 5-fold cross-validation using 5 different training algorithms in 50 binary classification data sets, right? So all those data sets are open, it's just an experiment. And the first step, I train all the models, all 5 models to each one of the 50 data sets using the default hyperparameters of these training algorithms, right? And I calculate the overall or average AUC using that strategy, that training strategy. And I got something around 79 AUC, right? .79. Okay, then I performed a grid search in each one of these algorithms combined with the data set, and I found a suboptimum or close to the optimum performance for each algorithm, but tuning the hyperparameters. And again, calculating the overall AUC, I got 0.83. So it's almost 5% improvement just tuning the hyperparameters, right? So tuning can be very important also. This is another why. Ensembling. Some people think it's pretty complicated, complex to build ensemble of models, especially in production and companies that must deploy a lot of models. But imagine using AutoML can do it automatically for you. The same experiment as before, instead of just calculating the AUC for each data set, I build a stacking and assembling of all the models, all the 5 models trained for each data set, right? Then, with the output of the stacking and ensemble, I calculate the average AUC and got around 8% improvement over the best untuned result from these data sets, right? It's another why. So tuning hyperparameters can improve around 5% in this case, this experiment, and adding ensembling plus 3% in average. Also, interpretability is very important nowadays. It's not so important to build a model, but know why the model is taking that decision when predicting something, right? It's very important in the health industry, in medicine and financial industry to know how the model got that prediction, right? And this topic, again, is trending, and it's very important for a data scientist to know how model works to explain to higher levels in the companies. And sometimes there are some legal issues related with the interpretability of the models also, depending on the country or the region. Okay, but the machine learning, there's a cycle. This is a macro vision of the cycle of the machine learning and what AutoML can do, right, inside that cycle of the machine learning. But the first problem before starting that cycle is defining the problem, gathering the data, and how to store the data, right? It's usually customized. Each company has its own way to store the data, how to access the data, if it needs to be scalable or not. So that part is still not automated by AutoML, but is very important step for the AutoML, because from that step, gathering the data, that we can build the data sets that we can feed to AutoML. Okay, so the first step, once you have the data, is just load the data, join tables. AutoML can do it automatically for us. Clean or drop errors or outliers. Perform some kind of data augmentation using artificial examples or some other strategy for augmentation. And this part is just the data preparation, data wrangling, right? But this also can be automated by AutoML. Analyze the data. Once you have the data sets input to AutoML, AutoML needs to have its own vision of how the data works. First step, discover the data, right? AutoML needs to detect if a variable is a categorical variable, numerical variable, what kind of variable, free text maybe this is just image, sound. So this is the first step for the AutoML. Then also AutoML can detect feature distribution, and based on distribution, there are ways to improve the overall performance if you combine different features correctly. Analyze the correlation between features, maybe between features, maybe between the features and the target, the dependent variable. Perform some clustering, automatic clustering at this step. And what I consider the most important, feature engineering, is the step that is pretty intuitive for humans, but it's very complex to teach a machine how to do it, right? Most of AutoML solutions nowadays use like a kind of brute force feature engineering to create more features to make easier or better the way the machine learns a problem. Okay, third step, train a model. Also, not all the algorithms are good for all the data sets, right? AutoML can choose a range of algorithms to be used to train using that specific data set. But at the same time, it's very important to choose a correct validation strategy. It depends if the rows are completely statistically independent, or there are some time variables between the rows. This is a time series. How the AutoML is going to choose to validate the models, right? If you're going to split by time, if you're going to split by random cross-validation, folds, or maybe grouped cross-validation. This step is pretty important. Then, AutoML can do the hyperparameter tuning. It's a very computer expensive step. The same for neural networks. The architecture searching for neural networks, it's also very computer-intensive task to find the best architecture that fits better to that data set. Feature selection also can be very computer expensive. It can take a lot of time just choosing which of the features can be dropped or kept in the model, right? For each model. Also, feature selection and hyperparameter tuning are tied in a way that if you remove a feature, probably it's going to affect the hyperparameter tuning. And at last, ensembling, right? Once the AutoML train a set of models, it's possible to choose which model are better to combine in order to build the final solution, an improved version of the solution. First step, test the model, right? Once all the steps before are done, it's possible to analyze the predictions if the predictions are according to what or the machine learning AutoML are expecting. Check for inconsistencies, calculate relevant metrics. You can have more than one metric. Compare model predictions. Compare all the models built in the data set in terms of predictions. How they are comparable, and prepare the model for model interpretability. Okay, Also, AutoML can deploy a model in production automatically, check for inconsistency of that model if it's working or it stopped working for any reason, maintain different versions of the models, and check for data health, right? Data health is very important, especially if data changes over time, or eventually there's a bug in the production pipeline that are inputting wrong data to the model. Okay, we talk about the challenge, but this is a real challenge I'm shown on that table. Imagine a machine that look at that table, right? You send that table to a machine and ask the machine, what are the variables? The first column, machine can say, probably it's free text, right? The second and the third columns looks like numbers. Machine will say, they are just numbers. And the last column are a mix of numbers with different punctuation, right? Like comma, dash, dot, and machine will get a conflict on that feature. But if we use the human intuition and we add the titles of each column, it's easier to define which feature is, right? For example, the first one can be just a categorical feature because there are repeating text on that feature, right? It's easy for us to detect it, but it can be hard for a machine to detect it. And categorical tests must be treated differently when processing the features. Zip codes also are related with latitude and longitude, or can be related, right? Geographical position. And there's a completely different processing for that kind of features if compared with single numerical features. The same, one of the most important features here, the third one, timestamp, right? If you treat the timestamp just as a number, probably you are going to mess the data. Probably when we split the data to do cross-validation, we mess with the validation strategy. This is very likely that we overfit the model doing that. So if we treat that feature as a timestamp, and we split the model by time, and also we can derive some features from that kind of feature, right? From timestamp, it's possible to derive hour, minute, day of the week, day of the month, year, and whatever time-related feature, right? And the last one can be a free input text. Maybe some people input text in different metrics, like foot and inch or meters, and also, depending on the country, it can input with the comma or with the dot, right? How to manage the machine to understand that kind of situation? This is one of the challenges of the AutoML right now. Okay, also related with feature discovery, it's possible to detect the feature distribution, right? What the numerical distribution of that feature? Probably, if you are looking for feature engineering, combining features with different distribution can add noise to the model. But normalizing and combining features with the same distribution usually can improve the model performance in terms of accuracy. Here as another example of detecting feature distribution. And at last, feature engineering. Feature engineering, it's a topic that it's a very vast topic, and there are infinite ways to do feature engineering, right? But right now, the best way to do feature engineering is using human intuition. And that kind of intuition is hard to teach a machine to do. So there are some open tools that do automatic feature engineering that are basically doing brute force feature engineering. They combine all the features with all the other features in order to just keep adding features to the model and comparing the metric against other models with less features, right? And there are many ways to do feature engineering. we can spend our entire lives just preparing feature engineering for a specific data set. There are infinite ways to do feature engineering. But there are some intuitive ways to do that. And that's what humans do pretty well, right? And in that part, we can add a lot of value to the models, feature engineering. Usually, also, feature engineering is the easiest way to increase the accuracy of a model. Because building different viewpoints of the same data set can make easier for the algorithms to learn. And eventually, it achieves higher performance doing that. For natural language processing, it's possible to do feature engineering also. For example, we can detect the language of the free text, right? We can use specific relations between the words for each language that can change for each language, like verbs, adjectives. Each language is different. Cleaning the text, right? There are many ways to clean in each language. There are different ways to clean. Find misspellings and maybe fix it. Perform some traditional approach like anagrams, TF, IDF, matrix transformations of the text, or even a simple bag of words. Also, the state of the art for natural language processing nowadays lies on huge embedding neural networks or deep learning neural networks, right? And the way we can use it to avoid training huge neural networks that can take days to train a model is to use the pre-trained huge neural networks to extract embeddings from the text in many levels. For example, at character level, at word level, at text or sentence level. And once you have that, that vector representation of each text, build a tabular data set, a matrix of values, and then use it to train a model. This is another way to do feature engineering with text, and in a fast way. The same for image classification. We can process images in many different ways, infinite ways to do that, actually. But the best way to do feature engineering with image is performing data augmentation, right? Like the picture of the cat, just with different transformations, right? Instead of feeding just one picture of the cat, we can feed multiple viewpoints of that cat. And usually this is the best way to generate more data for image classification problems. Image classification, segmentation, image-related problems. And the ultimate challenge for AutoML would be mix all this information together, solving a problem that have tabular data, image data, and natural language processing data all in one, right? It will be the ultimate challenge. Okay, automatic model fit. I already told about the validation strategy. The model must choose which validation strategy is best for that specific problem. Set a relevant metric. Not all metrics are good to solve all the problems, so probably one problem have a specific metric that's better to solve or to minimize the error. Choose a model to train, which model the AutoML is going to pick to train that specific data set. And finally, optimize hyperparameter or neural network architecture search. Regarding hyperparameter optimization, there are some classical and state-of-the-art algorithms, but I want to show you how hard it can be or how much time it can take. For example, that training algorithm based on a gradient boosting decision tree, light GBM, searching the internet page about the parameters, there are 60 different hyperparameters to set. imagine for each data set, there's a specific set of hyperparameters that performs the best accuracy for that data set, right? From that 60, right? So there are a lot of variations. Each hyperparameters that are infinite values. So it's a very complex problem to solve. Choosing the right hyperparameters to train a specific data set. And I also told you before, removing one feature from that data set, like using for feature selection, can change that hyperparameters, the ones that perform the best scores possible. The same for neural networks. Imagine neural networks with multiple layers, each layer with different sizes. What we can add between the layers, drop out, batch normalization, convolutional layers, time to sequence to sequence layers, and so on. So the possibilities are infinite, right? So searching neural network architecture is time expensive. Okay, this is just the minimum number of parameters to set to a gradient boosting algorithm. All in red are the parameters, and these are the default parameters. If I remember correctly, there are 16 minimum number of hyperparameters to set, right? Imagine each one is different for each data set. Okay, there are some classical hyperparameter algorithms, optimization. They are basically based on grid search and random search, the classical ones, right? But also there are gradient-based optimization, Bayesian optimization plus hyperband. It's a form of bandit algorithm mixed with Bayesian. And guess. The last one I said guess because it's possible, at least this library, scikit-learn, use the information from the data set to guess the best set of hyperparameters to start training that data set. So it's possible to use AI to predict it, right? Just animation to show you how the grid search and the random search hyperparameter works. Basically, in the grid search, we set not runs agents. We set some values for each hyperparameter we want to experiment, and the grid search just do all the combinations of all the values on all the parameters we set. It's just simple combination, right? It's like a matrix, like shown on the image, and the same is the random search algorithm. Instead of fixing the values for each hyperparameter, we fix the range of for each hyperparameter. There, we are going to take a random point from that range, right? Here is the grid search. For example, in this example, we have 3 parameters, each parameter 5 values. So the hyperparameter optimization algorithm you run for 5 times 5 times 5. So 125 times, right? All the combinations of the hyperparameter. One advantage of this algorithm is it can be parallelized. If we have 125 machines available, we can just send the jobs to all these machines, and in one fitting time, it returns all the results, all the metrics we are looking for, right? The same for the random search, but for each parameter, we set a range of values, right? In this case, we need to define the range. In previous case, we fixed the values for each hyperparameter. But in this case, we can choose the number of times we are going to run the search for the best hyperparameters, right? And it also can be parallelized. And the best hyperparameter is the one that provides the best accuracy in terms of the metric chosen for this specific problem. Bayesian optimization, It's it's an improvement from the previous algorithm, but it has some advantages and disadvantages. The biggest, how it works, first of all. First, the Bayesian optimization start with a random search for a few steps, and it built a dictionary of results of hyperparameter and results, right? Based on that dictionary of hyperparameters and results, it calculates the best point based on these previous results. It uses Bayesian inference to calculate that, right? So it's like to having a history of previous results, and based on that, we calculate the likely of the next set of hyperparameters that can provide the best performance. In these terms, as it depends on the previous results to calculate the next set of hyperparameters to try, it's a sequential algorithm. And this is the biggest disadvantage of this algorithm, right? But the advantage is it converges faster than the previous algorithms. With just a few iterations, it's possible to converge to the best set of hyperparameters. This is just a plot to try to understand better. On the top image, we see two results of two experiments with different sets of hyperparameter. Then on the middle image, they add one set of hyperparameter, and it scored worse than the previous one. And on the bottom image, we can see an X4 point. It's the 4 experiment, and it used the previous experiment results to calculate that point, right? It converged faster to an optimum local maximum in this case. And finally, ensembling. Combine n-fitted models in order to improve the overall accuracy of the solution, right? An AutoML system can build hundreds of models, but not always all the hundreds are good to ensemble in a final solution. That's why it's important to run some sort of model selection algorithm also to combine that algorithms. And how to combine also is important. It's not just a matter of average of the predictions. You can also use machine learning algorithms to combine all those models, right? So we are telling about a second level of training. The first level we train several models, and the second level we use the prediction of that several models together to train a new model on that predictions, right? Using that predictions. So that ensembling can be very complex also. Finally, model interpretability. I told how important it is to understand our data. For example, the Chewbacca was classified as a hunting dog, right? But for us, clearly is not a hunting dog. But why the model classified that way, right? This is what we're trying to understand when we perform some interpretability strategies on the model. And also, it's known that linear models are easier to understand in terms of interpretability than complex model like deep neural networks, right? So it's a trade-off between how much you want to understand your model and how much is the final accuracy you want from your model, right? But the final challenge is having a complex model completely understandable. This is one example of model interpretability from the paper of LIM. LIM is a Python library for model interpretability. In this task, it was trained several images of wolves and dogs, the husky dogs, right? And the model was told to classify wolves and dogs. That's it, right? And finally, for this image, the dog was classified as a wolf, right? But they have no idea why the dog was classified as a wolf, because looks like as a dog, right? Then using model interpretability gives us the B image, the explanation, right? What part of the image the model uses to understand that image as a dog, right? Sorry, to understand that image as a wolf, not a dog. The model thinks it's a wolf. So if you look, most of the snow present in the image was used for the model to understand it as a wolf, right? And in real, the model is classifying snow or not snow, because then they realize most of the wolf's images are with a background of snow in the image, right? They are taken in the snow. Wolves lives in the snow. It's part of this animal life, right? So the model is just learning snow. If the image contains any kind of snow, it's a wolf. If there's no snow, it's a dog. So this is one way to understand how the model is taking that decisions, right? And it becomes every day more important to have that kind of interpretability in the models. Okay, this is the magic of AutoML. AutoML is supposed to be very simple to use. If you know coding, you can program in a few lines of code. But there right now are tools that make our lives easier, like visual tools also, to do exactly the same. So in these 4 lines, I import the AutoML library, I set the AutoML class, and I configure just a few parameters. For example, time left for this task, and I choose 600 seconds, memory limit 4 gigabytes, and number of jobs, 4, right? We have 4 CPUs available for this job. Then we just throw the data set and the dependent variable, the target label, to the AutoML, and we wait for the 10 minutes. After that, we can start to use that AutoML model to make predictions. That's it. That's the idea, to make simple and controllable way to train models and acquire high performance, right? But of course, there are some limitations. For example, the time, the amount of memory usually we have available, number of CPUs available. It depends on each case. And usually, if you train the model for more time, usually you get higher accuracy in the final results also, right? So taking that into account, it's a matter of a trade-off between costs, model performance versus time, right? Why cost? Because right now in the world, we run a lot of machine learning, training, and predicting models, right? And to train a model, we need CPU time, CPU hours of work, and it costs money, right? For example, if you want a model to be trained in a small amount of time, we have basically only one way to do it. Increase the number of CPUs to process, sorry, 2 ways. Increase the number of CPUs to process that AutoML system, or make your algorithms better to train in less time, right? Improve the algorithm performance. But since the algorithm's performance is not always easy to implement or to make it better, training a model to achieve high performance is a matter of time and cost. How much time you have to train a model? You have hours, you have days, right? And how much you want to spend to train that model every day, right? So right now, it's a matter of finding the best trade-off for each case also. So we are talking about the challenge today. We talk about data set, join and merge automatically, automatic feature discovery, feature processing, imputation, engineering, feature selection, model selection, ensemble of models, hyperparameter optimization. but also one challenge I didn't tell, but it's very important, is for big data, is scalability. If the data fits and run, or we need to scale it to clusters, the cost, maintainability, interpretability, and make it deployable automatically, right? There are many challenges for the AutoML right now, and there are many tools also doing AutoML right now. But it's just to you to know how many challenges you are attacking here if you are using the AutoML. And the advantage, near zero complexity to the users, right? You just throw the data set and get the reward. Reduce costs of hiring ML experts. You don't necessarily need a machine learning expert to do that. You can use anyone to do that. But if you have a machine learning expert, it can be good in terms of you are making more experiments in less amount of time. Reduce human bias and errors. Humans tend to add a bias to the overall performance of a model, right? That's one thing that's good in Kaggle, because in Kaggle, usually the data sets are fixed. They are shown to you. They don't change until the end of the competition, right? But that data sets are prepared by experts, right? And that experts that prepare the data set have a lot of knowledge about the problem they are trying to solve. And usually they use that previous a priori knowledge to add some kind of biases to the results, right? And this is a bad thing. In Kaggle, each Kaggler that takes a new data set usually treated as a black box. They don't know the feature. They need to have the intuition about the features before starting to work on that problem. So AutoML also have that effect of reducing the human bias. Increase productive time to reward, right? You can have the model faster. You can have a fast insight about the data set performance. The first question when we have a problem is, but how much we can have in terms of performance? How much it will bring in value to our company, right? And AutoML you can do it faster, right? So faster insights about the metric you are trying to achieve, and you can deploy it very quickly also. You be sure also to be using the state-of-the-art in machine learning, because most of the solutions are using the state-of-the-art of all the machine learning algorithms inside. Can be easily scalable. It means in terms of scalability, if the data set you are dealing is huge, some AutoML solutions can do it easily for you, right, without much worry, and easily deployable also. Okay, that's it for the first talk. I would like to thank you guys again. Nobody's asleep, so it's good, I hope. See you guys in the second talk.
Ahora vamos a abrir un turno de preguntas por si queréis preguntarle algo a Gilberto sobre esta charla. ¿Alguien tiene alguna pregunta para Gilberto? Sí, por aquí hay una.
Hello. Hello, Gilberto. Do you recommend any AutoML tool?
Cool.
Do you recommend any AutoML tool?
It's a tricky question. I had to recommend the Apple solution because I work on that company, but I prefer not to recommend right now, today, right? I recommend you to use an open source AutoML tool like the one I told you, like Scikit-learn, to get used with AutoML. That's what I recommend. No commercial tool for a while, but I hope if you like, you can search for a commercial solution.
And is this the future of machine learning?
Uh, I believe is the future for machine learning. Yes, it. You are on the first steps of making it really, really good. But in the near future, we will have very extremely good solutions. And as I said, the biggest advantage of AutoML is anyone will use it in the future, can be able to use it. Like a spreadsheet, Excel spreadsheet, anyone have the intuition to put the values and use it to solve simple equations, right? I believe AutoML will be something similar. Anyone will have it at home, and I have a problem I need to solve. Oh, let's solve using machine learning, okay? So throw the problem and grab the results. I think this is the future.
Thank you.
Hello, Gilberto. Thank you. First, do you think it is worthy for a company to develop its own AutoML tool, or better bet on a vendor's one? And second, this is maybe more personal, do you use it when you win your gold medals, or maybe you have your special take and that's why you make the difference?
Yeah. Regarding building the AutoML tools internally to each company, as you saw, it's very complex. It depends the size of the team in the company. If you are willing to spend a lot of time develop the kind of tool, it's not simple. So it's a matter of balance. If it's really necessary to develop such kind of tool, or buy something that is already ready to be used, right? I would say it depends on the size and the money you have available and the time you have available. And about the Kaggle, I will talk it in the second talk, okay?
Okay, thank you.
Hi, hello. Thank you for your talk. I have one question. How do you deal with the overfitting when you do this performance optimization and all this kind of complex things?
Mm-hmm. Yeah, it's a good question. It's not easy to deal with overfitting. There's a lot of variables that can impact to overfit. But the first step is to define a good cross-validation strategy. One strategy that I use, for example, I first define if I'm going to use 5-fold cross-validation, 10-fold, n-fold cross-validation, or I use grouped k-fold cross-validation, or time-based cross-validation. This is one step. Once I define that, then I apply to all the models exactly the same cross-validation strategy to be comparable to each other, right? So I can compare the model performance. And at the same time, there's other strategies like bagging to avoid overfitting, right? Bagging with sampling. Some hyperparameters are good to avoid overfitting now, so setting these parameters correctly can avoid overfitting. But I would say the most important part is define the validation strategy correctly. If you define it correctly, it's hardly you overfit to a train set.
Thank you.
¿Alguna pregunta más?
Hay que aprovechar el momento que tenemos a Gilberto. Alguien que se anime.
So I have a question for everyone. Who here play at Kaggle or active at Kaggle? Okay, around 10, 15%. That's good. That's a good number. There any grandmaster here? No? And master? 2? Okay, that's great. Another question, please?
One more question.
So maybe I would like to ask Gilberto, what would be the role of the data scientist in this scenario where everybody would use, or many people would have access to ML through AutoML tools?
Excellent question. What are going to be, what the data scientist will do if there's AutoML all over the world. What is what will be left to the data science to do, right? Actually, a biggest part of the data science job is to find the problems to solve, right? And once it finds the jobs, acquire the data to solve that problem. It's not simple to acquire, to build a data set to solve a problem. It's even hard to find a problem that can be solved by machine learning and define how it can be solved by machine learning. But I believe if the data scientists can spend less time doing machine learning and more time defining the problem, it can be a huge increase in the productivity of the data scientist, right? It can just work with the results of the AutoML and defining the problem, right? You don't need to spend much time in machine learning because it's something that we have some kind of control how to do that automatically, right? That's my vision.
Okay, I have also a question regarding the health of the data, regarding the application in production. Let's say we have a categorical column encoded as an integer, and let's say that NA, it is you have agreed with IT guys that a null means NA. What happens if when change not only the format but also the semantic of let's say a categorical? They decided by themselves to use -1 or 0 for NA, or decided to change two categories between its values. So how could you detect with automatic tools this kind of semantic changes?
Yeah, there's no perfect solution for this kind of problem, but both for a human or AutoML system. Both you have hard times trying to detect that kind of condition of the values of the data. This is not an easy task, and there's no algorithm to detect it out of the box, right? This is, as you said, this is a very customized solution. It's not something that can be generalized. But why? Because even for a human, it's hard to say, right? Yeah.
Okay, thank you very much. ¿Tenéis alguna pregunta por ahí?
Bueno, si no, podemos guardar las preguntas para la segunda ronda de preguntas después de la segunda charla.
Bueno, pues muchísimas gracias, Gilberto. por esta
Thank you.
ponencia. Así que vamos a dejar que Gilberto descanse 5 minutos y
Okay. Thank you.
por the second, para la segunda ponencia. Y si queréis, damos paso ahora a los sponsors que nos cuenten también oportunidades que hay en sus empresas y a qué se dedican. Si queréis, empezamos con Ayesa, con Daniel Capilla.
Hola. Vale. Pues nada, buenas noches. Mi nombre es Daniel Capilla. Trabajo en Ayesa. Ayesa es una multinacional española con sede en Sevilla. Y aunque es una empresa de ingeniería, pues hoy por hoy está considerada una de las grandes empresas tecnológicas andaluzas. Desde Ayesa estamos apostando por el Machine Learning. Bueno, prueba de ello es patrocinio de este tipo de eventos. Y bueno, el ojo de parecer futuro hoy por hoy es el presente. Y nada, para mí fue un placer escuchar a Gilberto el sábado en Sevilla y está siendo un placer escucharlo aquí y simplemente agradecer a los organizadores por haberlo hecho posible y nada, muchas gracias a todos.
Muchas gracias. Bueno, muchas gracias, Daniel. Ahora Álvaro Fernández del Banco Santander. Gracias, Álvaro.
Buenas. Si me permitís, me gustaría hablar un poco de lo de AutoML que estabais hablando antes. De hecho, una persona de mi equipo ha preguntado, con lo cual aprovecho también y doy mi opinión. Bueno, yo soy responsable de Data Analytics en el Banco Santander España. Un poco nos encargamos tanto de la parte de ordenar los datos como de ordenar la analítica de los modelos. Entonces, yo cuando oigo la discusión de, oye, van a desaparecer los data scientists, se va a hacer todo automático y tal, yo es que me pongo enfermo, la verdad, o sea, que me pongo muy malo. Yo llevo más de 20 años haciendo modelos, de hecho no soy sospechoso de los algoritmos porque empecé programando redes neuronales en C hace 20 y tantos años, cuando no se llamaban deep learning, se llamaban redes neuronales. Sí, de hecho, si hay algún consultor en la sala y me viene a ver, por favor, que no evite términos de Big Data y cosas de esas. Bueno, entonces, a lo que iba. Nuestra experiencia nos dice que al final la gran mejora de los modelos está en los datos y no tanto en la igualdad de datos mejorar los algoritmos. Entonces, yo creo que el valor de un data scientist al final pasa primero por identificar que tiene un problema, o sea, ya incluso antes de generar las variables, identificar que tenemos un problema entre manos, identificar que es un problema que puede resolver con datos y qué tipo de variables son relevantes de cara a definir y a encontrar los mejores, o sea, el feature engineering, que se dice en inglés, encontrar cuáles son las mejores variables para ese modelo, ahí es donde aporta ese data scientist. A mí que en el paso final, en el 10% del tiempo, se aplica un algoritmo u otro, pues obviamente en carteras grandes nosotros encontramos diferenciales de en torno al 10% de lo mejorado de los modelos, pero os diría, en base a mi experiencia previa, yo vengo de riesgos y ahora estoy en una función un poco más cross, que la mejora de los datos te puede suponer una mejora del modelo de un 30-40%. Y os pongo un ejemplillo. Hay una fintech en Europa, bueno, no sé si sabéis cómo funcionan los scoring de admisión en préstamos, por ejemplo, que es el típico modelo que podéis pensar que hace un banco. También para que tengáis en la cabeza, el 85% de las decisiones de un banco van por modelo. O sea, los modelos somos empresas dirigidas por modelos matemáticos. Entonces, esta empresa, bueno, vosotros imaginad cuando vais a pedir un préstamo en una oficina, ¿cuánto ganas? ¿Tienes una casa? ¿Estás casado? No sé qué vas a pedir? ¿Qué importe? Bueno, pues esta empresa lo que dice es, oye, es más importante no cómo es la persona, sino cómo se comporta durante el proceso de contratación. Y os pongo ejemplos. Oye, una persona que contrata un préstamo a las 3 de la mañana, porque lo sabéis por la traza digital, va a desempeñar mejor o peor que una persona que contrata a lo mejor un día a las 8 de la tarde. Pues ya os digo yo que hay mucha diferencia. O una persona que escribe en mayúsculas, y esto aplica a los emails también, frente a una persona que escribe en minúsculas y escribe bien, pues hay mucha diferencia de comportamiento también. Una persona que cuando hay unos términos y condiciones se lo fuma, o otro que se los lee, ¿quién creéis que va a pagar mejor? ¿La decisión más razonada o la decisión más impulsiva? O, por ejemplo, cuando ponemos simuladores y calculadoras en la web, el dato que hay detrás de esa calculadora es la leche. Pero al final te dice que una persona se ha ido directamente al importe máximo, que no ha jugado con la calculadora, que no ha jugado distintos plazos. Entonces, toda esta traza digital, todas estas nuevas fuentes de datos, al final posiblemente termina entrando en un modelo más o menos tradicional. Pero ese modelo tradicional tiene una mejora importantísima respecto de los modelos anteriores porque usa unos datos que antes no usábamos. Yo antes no sé un cliente en la oficina que hacía. Ahora en los canales digitales sé perfectamente qué hace mi cliente a la hora de contratar. Entonces, para mí, el primer punto, y por eso quería, porque como sale recurrentemente, oye, el data scientist donde aporta es en levantar esos datos que después nos van a permitir hacer mejores modelos. Y si además de forma automática conseguimos mejores algoritmos para mejorar ese 10% adicional, mejor, pero el valor yo lo veo inicial. Entonces, bueno, en Santander lo que estamos haciendo al final es un equipo cross que lo que se dedica es a tutelar los modelos y la analítica de todas las áreas. Ya os digo que hay áreas como riesgos que están básicamente basadas en modelos y donde tenemos equipos especializados en datos, en arquitectos, que lo que se dedican es a levantar todas las fuentes de datos que tenemos en el banco. O sea, todos podréis pensar que el Santander tiene muchos datos, pues efectivamente los tiene, pero muchas veces nosotros tampoco lo sabemos. O sea, yo llevo 10 años en el banco, o bueno, no más, llevo 12 o 13, y cada día descubro una fuente de datos nueva, diferente. Entonces hay un equipo de arquitectura que su misión es decir, vamos a levantar todos los datos que tiene el banco, los vamos a meter en un entorno único, llamadlo Lago, llamadlo Data Warehouse, llamadlo X, pero en un entorno único, y aprovechando que están todos los datos juntos, vais a ver cómo salen mejores modelos. Entonces, hay un gran equipo nuestro que se dedica básicamente a la arquitectura, pero muy funcional, pensando en el uso. No la arquitectura tanto técnica, sino la arquitectura funcional. Y después tenemos un segundo equipo que lo que se dedica es más bien a hacer los modelos. Entonces, es un equipo más pegado a los negocios que se está dedicando a analizar las necesidades de cada área, donde hay gente que a lo mejor no tiene esos skills analíticos y no es capaz de entender que le vendría bien un modelo. Y lo que hace es hablar con estos equipos y levantar necesidades que se puedan resolver. Entonces, dentro de esto, pues tenemos una serie de programas de talents que llamamos, que lo que estamos haciendo básicamente es contratar a perfiles data scientist o bien con un perfil un poco más técnico para arquitectura o un perfil más analítico para la parte de data scientist. No sé si hay un email por ahí o una dirección, por si alguien tiene interés, pero vamos, es un proceso que tenemos abierto continuamente y la verdad es que estaríamos encantados de que los que estéis aquí, algunos ya están conmigo, espero que aplaudáis ahora mucho. Los que no estáis conmigo, pues oye, si queréis aplicar, tenéis por ahí alguna dirección donde estaríamos encantados de recibir vuestros currículums. Y creo que me he pasado ya de mi tiempo, ¿no? Así que nada, muchas gracias.
Ha sido muy interesante. Muchas gracias. Pues entonces vamos a dar paso a la segunda ponencia de Gilberto.
Espera un momentito, voy a contar... Hola de nuevo. No sé si conocisteis que la otra vez hicimos una competición interna que le llamábamos, que era de los miembros del grupo y tal. ¿Quiénes recordáis y sabéis cómo funciona esto de la competición interna? Nadie, ¿no? Pues bueno, por ahí alguno. Pues entonces os voy a contar la versión un poquito más larga para que sepáis cómo va esto. Pues mira, esto se nos ocurrió en uno de los primeros meetups. Que podíamos invitaros a todos a jugar una competición. Gracias. La idea es que todos nos metamos en la misma competición y el que quede mejor de todos los asistentes, pues les damos un premio. De los asistentes de aquí y de los asistentes de Sevilla. Esto lo hicimos una vez como un experimento y resultó, o sea, un éxito total. Hubo 3 personas que sacaron una medalla de oro. No esperéis que vayamos a tener ese éxito en cuanto a medallas, pero sí que estaría bien tener ese éxito en cuanto a participación, aprendizaje, compartir y demás, ¿no? Así que os voy a contar un poco cómo funciona esto. La idea es... ¿Cuántos sabéis cómo funciona el Public Leaderboard y el Private Leaderboard de una competición? Vale, la mitad, pero os lo voy a contar también. Bueno, pues cuando tú haces una competición, te dan un conjunto de datos, ¿no? Uno de entrenamiento y uno de test. En el conjunto de entrenamiento de test, tú haces un modelo sobre el train, lo pruebas sobre el test y se lo envías a Kaggle. Y durante la competición, pues vamos viendo un leaderboard, ¿no? Pues el que lo va haciendo mejor se va colocando más arriba, ¿no? Pero de todo el conjunto de datos de test, solo te están evaluando sobre un 20% o un 30% de las filas. ¿Para qué se hace eso? Pues para evitar que la gente haga overfitting del test set y por fuerza bruta y demás intente sacar algunas cosillas, ¿no? ¿Qué pasa? Que cuando termina la competición se olvidan esas filas y se utiliza el 80% restante de filas para hacer pues ya para evaluarnos a todos y sacar un leaderboard de verdad, que es el que llamamos Private Leaderboard, ¿no? Bueno, pues si este fuera nuestro Private Leaderboard, cogeríamos y quitaríamos a todos los que no son miembros de este Meetup ni el de Sevilla. Esos no cuentan para nosotros. Bueno, pues habría ganado José Antonio Guerrero, que fue nuestro primer ponente. José Antonio es GrandMaster, igual que Gilberto. Pero ¿qué pasa? Que no nos van a dejar jugar. Entonces, Gilberto también es miembro del Meetup, ¿sabéis? Entonces, no les dejamos jugar. I'm sorry, Gilberto. Habría ganado entonces en el puesto 97 de la competición uno joven aunque sobradamente preparado. Pues muy bien. Este 97 sería nuestro primero. En Kaggle se puede competir haciendo equipos. Yo os recomiendo a todos que hagáis equipos, porque compartís ideas, aprendéis mucho más, ¿no? Entonces, si hubieran hecho equipo, por ejemplo, Jaime y José, pues mira, anda, ¿qué hubiera pasado? Bueno, hubieran ganado. Mira qué bien. Os cuento más cosas, ¿vale? No nos está permitido participar a los organizadores por motivos obvios, pero antes han levantado la mano varios Kaggle Master. Nuestros Kaggle Master sí son elegibles para ganar esta competición, pues para meter ahí un poquito de caña. Bueno, pues, ¿cómo organizamos esto? Pues lo hacemos en un Slack. Tenemos un Slack, tenéis la URL en el grupo de meetup.com, lo tenéis en Eventbrite. Entonces, entráis en el Slack, veis la competición que más os gusta, nos ponemos de acuerdo y decimos, venga, pues esta. Y empezáis a competir y el que gane, pues le damos un premio. Bueno,